Hello, my name is Fawaz. I'm from Vrije Universiteit Brussels, and I'll be presenting our work on natural language explanations titled NLX GPT. When we say explainability, this is what really pops up to our minds: heat maps. However, heat maps are very limited in their expressiveness. They're also low-level, not fine-grained, and only present the first-order information. On the other hand, natural language explanations aim to explain the decision-making process of a model through natural text. For example, if we give this image and the question to the VQA system and it predicts a cat, then we want to understand why the model predicts a cat through natural text. Something like, it's a furry animal that has a long tail, sharp claws, and has whiskers. Previous models follow the predict-explain paradigm. Taking visual question answering as an example, the image is first fed to a vision backbone and the region proposal network to get region proposals for the image. The region proposals along with the question is then fed to the vision language model to get an answer for the question. The answer along with the multimodal features from the vision language model are then fed to an explanation model to get an explanation for the prediction in natural text. We observe two main problems in current models. Firstly, region proposals is a very computationally expensive task. In fact, many works since 2020 have been shifting back to using grid features. On top of that, we have the vision language model, which is very memory expensive. In fact, current vision language models can reach to over 300 million parameters. Therefore, both region proposals and the vision language model perform a bottleneck when these models are to be deployed. The second problem statement is that the answering model and the explanation model are completely independent pipelines. In other words, the same model which gave the answer should also be used to give the explanation. We therefore propose a simple and unified model which solves all of the previous problems. We get rid of the region proposals and the vision or vision language model, resulting in a simple model which only includes the vision backbone and the language model. The language model performs the two tasks of predicting the answer and explaining it simultaneously. We also aim to reduce the language model size as much as possible. We therefore utilize a distilled version of GPT-2. Our work is also online with many other works this year, which also unify the models and use end-to-end pre-training. We start by pre-training our model on image captioning, because image captioning is aligned with the downstream task of text generation, and it also provides comprehensive image understanding by describing objects, their attributes, and their relationships. In fact, Vertex, a work published last year, shows the power of image captioning in pre-training for downstream tasks. After pre-training, we fine-tune the model on 4 natural language explanation tasks: visual question answering, action recognition, visual entailment, and visual common sense reasoning. We simply predict a single text containing the answer and the explanation together. Our work achieves the state-of-the-art on most metrics. We advise to see the paper for qualitative examples. We then measure the biasness of our model to the data by measuring the diversity of the answers to similar inputs. To measure the biasness, we propose a retrieval-based attack evaluation framework. Given the text query, for example, the question, we feed it into an image text retrieval model to retrieve similar images close to the text in the embedding space. Each of these images, along with the text query, is then fed to the explanation model to get an explanation. We then encode the explanations through sentence BERT and measure the diversity of the explanations through the gram matrix. Similarly, we can do this for vision tasks. Please note that the retrieval process is only done once. Therefore, this evaluation method is still fast. We can see that very similar images have a low intradistance. We also propose an evaluation framework which focuses on the semantics and the context of the explanation. We want to measure how good the explanation justifies the answer. If it does, we assume that the answer can be predicted back. We feed the question and the generated explanation from our model to a new language model and aim to predict the answer back. We measure the accuracy as the evaluation criteria. We also evaluate the effect of pre-training and find that it really helps our model. Thank you. The code is available online.